Algebra 2 students. This week we are going to be reviewing some skills from Algebra 1. And these skills are things that you probably practiced in geometry as well. So we're going to start today with 1.3 is the section title, and this is estimate and simplify square roots. Okay, so first of all, some vocabulary. We have first the radical symbol, okay? That's this square root symbol, okay? We then have the radicand. That would be the 16 underneath. And then typically when we think about what's the square root of 16, our answer we come up with is 4. That is called the principal root. But we all know that -4 times -4 is also 16, so that is also a valid answer, but it is not the principal root. Sometimes what we do is we write our answer with this plus and minus symbol to show both answers, +4 and -4. Another thing here that we want to make sure we review are our perfect squares. Perfect squares are numbers that we can take the square root of and get a whole number answer. Our perfect squares are 1, 4, 9, 16, and where these are coming from is 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and so on and so on. So our next perfect square would be 5 squared, which is 25, and then we could keep going, 36, 49, and so on. Okay. So now that we have some vocabulary under our belt, let's review the properties of square roots. Okay. First one, product property of square roots. What we can do if we have a number under a radical is we can split it up, and that allows us to simplify that radical. Alternatively, like you can see right here, okay, if I have the square root of 8 times the square root of 2, I don't know the square root of 8. I know it's a decimal. I don't know the square root of 2. I know that that is also a decimal, but I could multiply them together, and I know the square root of 16 is 4. So this principle, or this property, works both ways. We also have the quotient property of square roots that works in a similar fashion. So if you have a fraction underneath your radical symbol, you could take the square root of the numerator, the square root of the denominator, and simplify. Or maybe you have something like this next example, square root of 18 over the square root of 2. Again, we have two decimal answers, but we know that 18 divided by 2 is 9, and so we can take the square root of 9 and get 3. So these properties allow us to simplify our radicals, and you're just going to have to look at what's going to work out for you. Next question, what are like radical terms? Like radical terms have the same number underneath the radical. Unlike radical terms have different terms under the radical. Okay, so our goal is to simplify each expression. When we are simplifying radical expressions, we want to make sure that any square root that can be taken out is taken out or factored out. And we also cannot have a radical in the denominator. Okay, so those are the two things we're going to check for. So let's start with letter A, the square root of 32. We need to think to ourselves, are there any perfect squares that go into 32? So what helps me is if I make a list of perfect squares at the top of my paper. So just like we had on the previous screen, we had 1, 4, 9, 16, 25. I'm going to stop there because that probably will get me what I need. So do any of those numbers go into 32? 4 does. So we can break this down. We know the square root of 4 times the square root of 8 is equal to the square root of 32. But we also know the square root of 4 is 2. Okay. Oh, wait. Is there another radical in there? There is. I know that the square root of 8, I can break that down into the square root of 4 times the square root of 2. Again, we know that the square root of 4 is 2. And now we can put it all together. 2 times 2 is 4, so we have 4 square root of 2. Now I could have done this quicker, but it didn't jump up out at me as quickly. I guess that's what a summer off of math does. I could have also used that factor of 16 and it would have gone a lot faster. So I could have said 16 times 2 to break it down at the beginning, and then it would have saved me less work. But this is a good way to show that no matter what factors you think of, this is still going to work out for you in the end. All right, next one, square root of 25 over 36. Hopefully you'll notice right away those are both perfect squares, so we're going to split it up and simplify them and then have our solution. So we've got the square root of 25 over the square root of 36. Square root of 25 is 5, square root of 36 is 6, and it's that simple. Onward, square root of 3 times the square root of 12. Okay, well, we have to simplify it, and I know that 4 is a perfect square and it goes into 12. But before I keep going that far, I'm going to look at them individually. So I've got the square root of 3 is a decimal. But remember, I can also put them together before I take the radical. So if I put them together and I multiply first, 3 times 12 is 36. Now what do we know about 36? It's a perfect square. So that's going to be our ticket right here. I'm just going to switch colors kind of back and forth so my examples don't get too messy. So I can simplify this to be the square root of 36, and then we all know the square root of 36 is 6. All right, last simplifying problem. We have the square root of 500 over the square root of 5. I know that those are decimals, so I think what I might start with is simplifying 500 divided by 5 and then take the square root, similar to what we just did. So 500 divided by 5 is 100, so this is equal to the square root of 100. The square root of 100 is 10. Notice in all of these examples, I circled one answer. Okay, it says simplify the expression. It doesn't say find all values. So by simply writing the principal root, I'm just fine. Okay, if you're going to need to write a negative answer, there would be something in the directions about finding all solutions. And we usually don't do that unless we're solving an equation. But right now we are simplifying an expression. Okay. We're going to add or subtract, and our rule here is we can only add and subtract if they are like radical terms. Remember, like radical terms have the same number underneath the radical. And then what you can do is simply use the sign and the numbers in front to do the rest. In our first example, we have like radical terms. So what we can do is just add 9 and 7, and then that radical 3 tags along. 9 plus 7 is 16. And then we just keep that square root of 3 there. When we look at this next example, though, we do not have like radical terms. But let's look at that 20. Are there any perfect squares that go into it? Yes, there are. 4 and 5. So let's work on that 20. So we have the square root of 20. I don't know why I have a weird line that showed up there. Is equal to the square root of 4 times the square root of 5. We all know the square root of 4 is 2. We know the square root of 5 is irrational. So this is now simplified. And notice, now that I've simplified it, I have a like radical term. So I can now write down my 6 square root of 5 in front. And I am now going to subtract these coefficients of 6 and 2. 6 minus 2 is 4. So this simplifies to 4 square root 5. All right, next topic for simplifying. I mentioned it before, but I did not use the correct vocabulary. You cannot have a fraction with a radical in the denominator. Okay? When that happens, what we have to do is called rationalizing the denominator. To do this, we're going to multiply both the numerator and denominator by the denominator that makes that a perfect square. I think this is the topic that I know when I taught geometry, I remember doing this a lot in the geometry class. So I hope that this comes back to you pretty quickly. So when I look at example A, I see there's a radical in the denominator, so it is not considered simplified. So in order to rationalize the denominator, I have to multiply the denominator by the square root of 2, because the square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. So basically, what you're going to have to do is whatever you see in the denominator is what you need to multiply it by. But we know we can't just go around multiplying fractions by 1 over something. But we can go around multiplying fractions by 1. So in order to make this equivalent to 1, I have to multiply the numerator by the square root of 2. Now I'm going to simplify this expression. 3 square root of 5 times the square root of 2. I multiply the two things that are inside the radicals. These are not like radical terms, but right now I'm not being asked to add or subtract. I'm being asked to multiply. So the 3 remains the coefficient, and then 10 becomes our radicand. The square root of 2 times the square root of 2 is simply 2. Before you stop and circle your answer, you'll want to check your radical, the square root of 10, and see if it's simplified. Are there any perfect squares that go into 10? Factors of 10 are 5 and 2. No perfect squares. So this is it. It is now simplified. Let's do one more. This time we have the square root of 8 in our denominator. So we need to multiply both the top and the bottom of our fraction by the square root of 8. Square root of 2 times the square root of 8 is the square root of 16. Square root of 8 times the square root of 8 is 8. Again, simplify if you can. Do we know the square root of 16? Absolutely. And we can reduce our fraction down to 1/2. All right. To conclude, I want you to see if you can come up with 2 different ways to simplify this expression. After you've come up your 2 different ways, I want you to go ahead and start your assignment. It's just about 11 problems on page 24.